Okay, so here's an angular momentum problem. Okay, a thin circular ring of mass m and radius r is rotating about its axis with a constant angular velocity omega. Okay, thin circular ring rotating about its axis. So I'm assuming it's going to be like, like the axis would be here and then the ring is like, rotating around like this, right? Like a hula hoop, I kind of think. With a constant angular velocity of omega. Okay, so this is going to be the initial. Okay, and then the final, somehow like a miracle, they're putting two objects at opposite ends. Okay, and this is capital M, radius r. Okay, afterwards, the ring now rotates with an angular velocity of what? Okay, so this is a conservation of momentum. So the initial angular momentum equals the final. Okay, so this is going to be I initial omega initial equal I final omega final. Okay, final will be I initial omega initial over I final. Okay, now we just got to figure out what the moment of inertia is. Okay, let me just check what a thin hoop is. I think a hoop is mr squared, yeah? Moment of inertia. Hoop. I think isn't it mr squared? Yeah, mr squared. Okay, all right, so I initial is going to be mr squared omega naught. Okay, and then the final, right, it's going to be the I final is going to still be mr squared for the hoop, but then each of those masses are now an r away, like this, right? Okay, so I think I final be big M r squared plus 2 little m r squared. Okay, so m r squared plus 2m r squared little m. All right, and then let's see, can we cancel out an r squared maybe? So mr squared omega, let's factor out an r squared. So I have m plus 2 little m, that'll cancel. So m omega naught, big M plus 2 little m. Okay, is that a choice, I hope? Let's pray for the best, huh? That looks like D, yeah? Omega M, yeah, C. Omega M, yeah, C, I think. Okay, all right. So again, there's a lot of problems like this where the shape changes somehow, like that's the idea behind the skater, right? Like the shape changes, therefore the velocity, angular velocity will change, okay? And then you just have to remember how to find this moment of inertia, okay? 2-point particles added on, all right?